Vectors have both a magnitude and a direction. A unit vector is a vector that has a magnitude of 1. Any vector can become a unit vector by dividing it by the vector's magnitude. Here we have a vector which moved in the horizontal direction of 3 and the vertical direction of 4. In order to find the magnitude of vector, it will be the same as finding the length.
So in order to find the magnitude in this situation, we would do equals the square root of 3 squared plus 4 squared, since this is the right triangle. So after you do this, get the square root of 9 plus 16, get the square root of 25, which is 5. So here you find the magnitude of this vector is 5. So like we said before in the unit vector, we have to divide the components by 5. So we would get 3 over 5 and 4 over 5. And we would do the same thing as we did before to check for a magnitude of 1. So we do the square root of 3 over 5 squared plus 4 over 5 squared, which would become 9 over 25 plus 16 over 25 square root, which would equal the square root of 25 over 25, which equals 1.
Here is another practice problem. This one is for unit vectors. Pause the video now if you don't want to see the answer. Try to find the unit vector. Okay, so what you have to do here is you have to go 7 squared plus 5 squared, radical that, and that would equal the vector of A. So vector A, magnitude of vector A. And then you have to go that equals radical 49 plus 25, which then equals radical 74. And then, so now, in order to find the unit vector of something, you have to divide the magnitude, or the components by the magnitude. So it'd be 7 divided by radical 74 and 5 divided by radical 74. And seeing as this is a radical in the denominator, you would have to multiply by 74 for both of them. So it'd be 7 times radical 74 over 74. And this would be 5 radical 74 over 74. And that would be how you find the unit vector.
So here we have vector b, and the change in x is 6, and the change in y is 8. Now to find the magnitude, we would have to use the distance formula or Pythagorean theorem, because it's actually a right triangle. So we take the square root of the change in x squared plus the change in y squared. So now you have 36 plus 64. And now you have 100 when you add them, and this becomes 10. So to find the unit vector, we would need to divide the components by the magnitude. So that would be 6 over 10 or 3 over 5, depending on how you want to do this. And actually, let's do 6 over 10 and 8 over 10. And let's do this. And let's actually check our work and make sure this is the unit vector. So if we square them, we will get 36 over 100 plus 64 over 100. And let's see now, we got magnitude of B Add them together, you get 100 over 100, which simplifies down to 1. Square root of 1 is 1. So I would like to go over the importance of unit vectors. So they have this ability which, when you multiply by any number, you can extend or decrease the size. It also tells you the direction and degree, and both of these allow you to simplify a ton of computer coding and APIs. In physics, they're sometimes used in complex formulas, and basically without it, we wouldn't have these kind of things we would have today. Like being able to swipe in a application to play a game. This concludes lesson 12-3, unit vectors. So see you guys later.